Hello, good students, and welcome to Radian Measure Part 1. I've drawn a circle here, and I'm going to tell you, using this circle drawing, exactly what 1 radian is. Now, first of all, when we're talking about radians, we're talking about how to measure how big an angle is. Just like in the past, you used degrees to measure angles. This is a new way to measure how big an angle is. So, it's just a different measuring device. And here's what it actually is. If you take the arc length and you make it equal to the radius of the circle, so this arc length would be r, then that is what we call 1 radian. So this, if I'm now in radians, 1 radian means you have the arc length of the sector equal to the radius of the circle. And that is what 1 radian is. Okay, so now you might say, well, that's very nice, but I wonder how big that is in degrees. How could I figure it out? Well, I'm glad you asked, because what we're going to do is the following. We know this is 1 radian, but what I want to do now is say, okay, how many degrees is this 1 radian? So equals, let's just call it theta degrees. Okay, and that's what I'm going to figure out now. So I'm going to use the sector angle of theta degrees compared to 360 degrees for the full circle. And what I'm going to do over here is say I know what my arc length is. It's r. And then on the bottom is the circumference of the circle, which is 2 pi times r. So that's just using our 2 equivalent ratios. Only this time, what I'm solving for is theta. So I'm going to cross multiply. So to get theta, I shall go r times 360, and then divide that by 2 pi r. And you can see I can do a little bit of canceling. It actually doesn't matter how big r is. So it cancels right out of there. And basically, if I simplify it, it boils down to 180 divided by pi. Now, you might not be happy with that answer, and I would agree. It'd be kind of nice to know, well, approximately how many degrees is that? So if you go 180 divided by pi, you get 57 and a bit. So 1 radian turns out to be just over 57 degrees. All right, so there you have it. That's what a radian is. Now, let me show you a more useful way of converting back and forth between radians and degrees. Because albeit this is nice, but this is kind of time consuming. So what I'm going to do, let me just clear off the screen here. And what we have just discovered is this. 1 radian is the equivalent of 180 divided by pi in the world of degrees. Okay, so this is 1 radian is this many degrees. Well, why don't we multiply by pi to get rid of the fractions? So now I have pi radians is the equivalent of 180 degrees. And this is what you want to memorize. It's a very useful way to convert back and forth. If you just remember pi radians, or 3 and a bit radians, is 180 degrees, boy, does it make it easier to do your conversions. So let me just do an example of that and show you this in action. So let's say we were going to do the following. Somebody said, I really want to know what 300 degrees is in radian measure. Okay? Here's what you do. Right underneath the degrees, we are going to use the whole notion that 180 degrees is the equivalent of pi in radians. So keep your degrees lined up. So right underneath, I'm going to write, well, 180 degrees I know is pi radians. Hey, why don't I just treat this as if this was like 2 fractions here, and then I could cross multiply and divide. Okay, so to get my answer up here, I'm basically going to go 300 times that by pi and divide by 180. Now I could work out approximately what that is on the calculator. If I did that, let's see, I went ahead and I got about 5.2 radians. So yeah, this is about 5.24 radians. Typically, though, they leave it as an exact number in lowest terms. So if I did want to simplify this, I could get rid of a 10 from the top and bottom. And then I got 30 and 18. Both of those numbers are divisible by 6. So I could write as an exact number 5 pi over 3 radians. So that is my exact answer. Or if you prefer, depending on whether it's a contextual problem, that's the approximate radian equivalent of 300 degrees. So that's converting from degrees to radians. What about we do one where we have radians and we're converting to degrees? It pretty much works the same way. So let's just say we've got something like 2 pi over 5 radians. And somebody says, I want to know what that is in degrees. By the way, I've been writing a little r here because we're new to this. Typically with radians, they just don't write anything. They just would leave it as 2 pi over 5, and we're going to convert that to degrees. And the assumption would be this would be, therefore, radians. Anyway, I'm going to use my equivalency here, which is for radians, it's pi, and in degrees, that is 180. And now I can just cross multiply and divide. So to get my answer in degrees, I'm merely going to go 2 pi over 5, times that by 180, and then divide the whole thing by pi. Now, it may look uglier. Well, okay, let's just take it one step at a time. Let's divide the 5 into the 180. So 5 goes into 180. Let's see, 3, that goes in there, and then carry so 36 of those. So this is going to look like this. I'm going to have 72 times pi, and then I'm still dividing by pi. So look at that. These pi's cancel, and I'm left with just 72 degrees. So 2 pi over 5 is the same as 72 degrees. Awesome. Okay, now, before I leave you, I want to make sure we're very clear on some really, really important radian measures. So by that I mean there are certain angles in degrees, and these are kind of the important angles. And they're important because we see them in our special triangles. And I just want to make sure that we're clear on these important angles in both degrees and in radians. So I'm just going to leave you with the quick conversions of these. These are ones that you're probably going to memorize even if you don't want to memorize them, because they're just used all the time. So like, suppose you had 30 degrees. Okay, what would that be in radians? Well, if we did the conversion, it's basically like saying you took 180 and divided it by 6 to turn it into 30. So if we take pi and divide it by 6, that's the equivalent in radians. If we took, let's just do another good one, is 60 degrees. That's kind of like saying 180 divided by 3. So this would be like pi divided by 3. 45 degrees is important. And that's like saying we take a quarter of 180. And so we're going to take a quarter of pi. And another really important one, and that's where I'm going to stop, 90 degrees, well, that's half of 180, so it's half of pi. So these are the radian equivalents of these very important angles. Important because we see them a lot, and they show up in our special triangles. So more on that later. So I'm going to stop for now.